Here in this video, we are solving two simple questions based on semiconductor devices which were given in the NEET examination in the previous years. The first question is a very simple theoretical question based on transistors, which says for a transistor action, which one of the following statements are correct, right? So first of all, to answer these questions, we shall have an idea that what is a transistor is, right? So a transistor is a device with three terminals. The first thing is it has three terminals and three parts too. So in a flat way, if I have to show, it will have a base, a emitter and a collector. For each of them there is a node which can be further connected in the circuit. So it's very clear that input I need two terminals, output also I need two terminals, altogether four, but we have only three terminals. So one terminal is common, shall be used as common for both input as well as output. So basics. So I have done a detailed discussion about transistors in the video of that particular chapter. You can go and see. Here I am not going into the details. See, the first option I will check. Base, emitter and collector region should have the same size, right? So that need not be the case, right? So generally emitter is somebody who is say little, moderately doped, highly doped. Base is lightly doped, collector is moderately doped. Therefore they can depend on the size of the device, so they did not be having the same sizes. See the second option. Both emitter junction as well as the collector junction are forward biased. That is also wrong, because the input is always in forward bias and the output is in reverse bias. That's how a transistor works. So this is also wrong. The base region must be very thin and lightly doped. This is correct, because base is somewhere in between emitter and collector, which acts like a region which connects the other two regions. So it's a thin region, it's a lightly doped region. That's correct. Base, emitter and collector region should have the same doping concentrations. As I already told you, that is wrong. So the only option that is correct here is the third option. That's a correct option. So it's a simple theoretical question. Let's have a look at the second question. What does this second question says? In the circuit shown in the figure, the input voltage is 20 volts. Here the voltage is given for us as 20 volts. Here also there is a 20 volts that's available. VBE as well as VCE are equal to 0. The values of IB, IC and beta are. See, this is the base. So the current passing here I have to find out, that is called IB. We can clearly see in between these points voltage is 20 volts, because VBE is given for you as 0 volts. So I can write V equal to IR. So at base, voltage available is 20, I is I base, resistance given for you is 500 kilo ohms, that is 500 into 10 power 3. So I base is 20 by 500 into 10 power 3. This is 2 by 5, or else 20 by 5 into 10 power 5, 3 and 2, this is 4 times. So 4 into 10 power 5, that is equal to 40 into 10 power 6, that is 40 microamperes. So base current is 40 microamperes. So both these are possibly right options. These two are definitely wrong options. We are able to eliminate two options. Let's work out the same at the collector, at this part. I have worked at the base. Now let's work at collector part of the given circuit. Again, V is between this and this. Here voltage is given for you as 0. Therefore voltage difference is IR, that is 20. I collector I have to find out. Resistance is given for you as 4 kilo, that is 4 into 10 power 3. So I collector is 20 by 4 into 10 power 3, that is 5 into 10 power minus 3, that is 5 milliamperes. Of course, then the only option that's available with that is 5 milliamperes, because this was already gone wrong. So, this is automatically a wrong answer. C also, D is an answer, but we can work out with the other things also. Beta is a current amplification factor in a common emitter configuration. As emitter is common, output is at collector, input is at base. So, delta IC by delta IB. Delta IC is given for you as 5 milliamperes, 5 into 10 power minus 3. IB is found as 40 microamperes, 40 into 10 power minus 6. So, 5 by 40 means 1 by 8 becomes 10 power plus 6, therefore, it will become 10 power plus 3. This is 1000 by 8, so its value is 125, which confirms the fourth option again. So, the answer for that problem is the fourth option. That is how we solve this question. Thank you for watching.